conclude this course by introducing functions. The idea is that we have two variables and they're related to each other by some formula. Then we can plot the related values between the two variables on the Cartesian plane. A function is a rule, or formula, that relates two quantities together, and the graph of the function is the graph of the formula on the Cartesian plane. Let's illustrate this concept with a simple example. Let t and d be two variables. The t will be the time variable, and it will measure past 12 p.m. The d will be the distance variable. It will measure the distance traveled in a car. Suppose we start driving the car at 12 p.m., so that 12 p.m. is our initial start of the driving. For simplicity's sake, we'll say that we drive at a constant speed of 40 miles per hour. Of course, this is a huge oversimplification. When we drive, we sometimes go faster, sometimes go slower, sometimes we stop during traffic, but we're keeping this example as simple as possible for simplicity's sake. So let's just say we're driving at a constant speed of 40 miles an hour for 4 hours straight. There is a relationship between the two variables, t and d. The distance that we travel depends on the time, t. After 1 hour, we travel 40 miles, so that when t equals 1, d equals 40. After 2 hours, we travel 80 miles, so that when t equals 2, d equals 80. We travel for a total of 4 hours, so when t equals 4 at the end of our trip, we have a d of 160 miles. The formula is d equals 40t, and that's the function between these two variables. This formula describes the relationship between t and d. It says to get d in terms of t, we compute 40t, and then say d equals 40t. Based on this formula, if you're given any time, you can easily find the distance traveled by substituting that value into the t of the formula. The way we graph the function is by plotting points between the two variables. The horizontal axis is the t variable, and the vertical axis is the d variable. We plot all points between t equals 0 and t equals 4. So basically, the y-axis is d and the x-axis is t, and the equation d equals 40t is basically the curve of y equals 40x, which is a line with the slope of 40 and a d-intercept of 0. Let's consider another example. Suppose that a computer company sells their laptop at $1,000 and their sales are 100,000 laptops. The company estimates that for every $100 increase on their laptop, they lose 20,000 sales. So for illustration, if a laptop is sold as $1,200, it means their estimated sales are 100,000 minus 40,000 equals 60,000. If they reduce their price by $100, then their estimated sales will go up by 20,000 to about 120,000. At what price should the company sell their laptops to maximize their profits? Well, let S be the number of sales. The two variables x and s are related to each other, as the number of sales depends on the price per laptop, x. Let P be the profit that the company makes at price x. Based on what we said, P equals x times s, which means that the profit is the price per laptop, x, multiplied by the number of sales, s. We need to find for what x will the quantity p be maximized. For convenience, let x be measured in thousands of dollars rather than singles. So x equals 1.5 would mean $1,500 per laptop. And let s be measured in hundreds of thousands of dollars, so that s equals 0.5 means 50,000 sales, and s equals 1 would mean 100,000 sales, and so forth. When x equals 1, we know that x equals 1. So when x equals 1.1, we know that s equals 0.8. When x equals 0.9, we know that s equals 1.2. When x is 1.2, we know that s equals 0.6. When x is 0.8, s is 1.4. Let's plot these points on the Cartesian plane, with x being the horizontal axis and s being the vertical axis. The function between x and s will be the formula, or equation, of this graph. As the graph is linear, we already discussed how to find the equation. So it's assumed at this point that hopefully you know how to find the equation of this line, as that's a topic that was covered previously in this course. The equation of this line is s equals negative 2x plus 3. The formula for finding s when x is given, is negative 2x plus 3. Substitute the value for x, and we get the value for s. Okay, so that's the relationship with sales. But what about the profit? Well, the profit is P equals S, or sales, times X, which is the price. Since we know that S is negative 2X plus 3 from the equation we saw before, it means that the profit is given by P equals negative 2X plus 3, which is the S, times X, which is the S, which is the same thing as negative 2x squared plus 3x when you distribute it. This is a parabola. Let's graph the parabola with x being the horizontal axis and p being the vertical axis. To maximize the profit is to find the maximum point on the parabola. The formula, negative 2x squared plus 3x, is the function from x to p. It takes a number x and associates to the correct profit p at this value of x through the formula p, or the profit, equals negative 2x squared plus 3x. Now we know how to find the maximum point of a parabola. It's the turning point, which is at negative b divided by 2a, which in this case is negative 3 divided by 2 times negative 2, which is the same as negative 3 divided by negative 4, which is positive 0.75. This means that the company needs to sell their laptop at about $750 to maximize their total profit based on sales. Let's take a look back at these examples again. In the first example, we described the function between d and t, the function between distance traveled in a car and time. The standard notation that we used is to write d of t. The notation of d of t symbolizes that the quantity d depends on the quantity t. The formula for d of t is d of t equals 40t. So if t equals 2, then d of 2 is 40 times 2, which is 80. This means that the distance traveled after t equals 2 hours is d of 2 equals 80 miles. In the next example, we had the formula s of x equals negative 2x plus 3. Again, the notation s of x symbolizes that sales depend on x and that the relationship is given by that formula. If we want to find s of 1.1, for example, we simply substitute s of 1.1 equals negative 2 times 1.1 plus 3, and then we can compute the value of x. In this example, with the profit, the last one we did, we had the function p of x equals negative 2x squared plus 3x. So the maximized profit at x equals 0.75 would be p of 0.75 equals negative 2 times 0.75 squared plus 3 times 0.75 equals, overall, if you multiply it out, 1.125. That is $112,500 based on the units we're using. When we have two quantities that depend on each other, a function is the formula that relates them together. Consider one last example. Suppose that the temperature in a university is air-conditioned. When a temperature reaches a certain level, the air conditioner turns off and the university slowly heats up. When the temperature is high enough, the air conditioner turns back on to lower the temperature. Suppose class starts at 12 p.m. or 12 noon. Let t, lowercase, be the time past noon so that t equals 2 will be 2 o'clock p.m. Let capital T, uppercase, be the temperature in the class at a given time t. If every few minutes we check on the class temperature and note the times when they happened, we will get a graph between lowercase t, the horizontal axis, representing the time, and capital T, representing the temperature, the vertical axis. To find the function between the temperature and the time, or capital T and lowercase t, is to find the equation of the curve that has this graph. Let's say, just for illustration, that we plotted all to a point and got a graph that looks something like this. So based on this, the t of 5 is about 15 degrees, and t of 8 is about 21 degrees, all in Celsius degrees, of course. To find the function for t is to find the formula T of t equals whatever the formula is. We're not going to discuss how to find this formula, as we never discussed trigonometry, which would be required to get this exact equation. If you happen to be familiar or interested, the formula for this curve happens to be T of t equals 18 plus 3 sine t. Now that we have a formula, we can simply substitute that value of the time, or lowercase t, into the equation to get the corresponding value of temperature, or uppercase T. This completes our course on algebra. There are many more topics that we never discussed, but these are some of the fundamental concepts which will all be developed in more detail in a more advanced course. Thank you for watching.